absolutely do have to have one, or can we just?
Your circles won't be off.
Yeah, your circles will be off, so your epicenter will be off.
Yeah. And then she doesn't bring any, I know Dollar Tree has.
If somebody will email me or message me or call me before class on what's today, Wednesday, Monday, I'll bring some, they're safety compasses, the kind that I used in high school with my high school classes. So if somebody will remind me, I'll bring them Monday to class. Y'all bring your earthquake papers.
So we,
yeah. The earthquake papers that y'all are, that earthquake project, I will try to send some compasses down to Mark Tree. If I don't forget, I'll send them with Miss Rachel Zademan, and somebody may have to go get them from her. And y'all can use them in class on Monday.
Have you looked at mine? I sent her it.
I haven't had papers. I haven't looked at them yet.
Okay.
I'm still trying to get test graded.
Okay. So
And,
training from today to Monday?
it's the 7th. Whenever the 7th is when it's due.
Okay.
And but I'll send some compasses down for y'all to use if you want to bring your project. And then if you want to redo it,
81 by the way. Sorry.
if you want to redo it, then you can redo it on Monday and resubmit it.
Yeah.
So, all right. I'm trying to look. We were talking in here before y'all got logged on about the factoring the algebra, and I found the algebra tiles, and these are supposed to be the electronic algebra tiles. That's the words I was looking for. So if you have maybe say 2x, and I don't know how to get a plus, but we'll consider this plus 1 times x
We did 35.
plus 3. So these are our two functions. They're both plus. I don't know how to write them otherwise. And I don't know how to do a split screen. Let's see. Okay, Mark Tree, tell me, can you see my,
Your keyboard.
okay, got the keyboard, now you can see the white notebook paper. Can you see the algebra tiles on the other half of the page too?
Yes.
Okay. So if, zoom this in, maybe. Yeah. I have to learn to manipulate this thing. Okay. So what we're going to do is do 2x plus 1. No, I'm going to switch back and forth. And then x plus 3. So we're going to multiply these together. All right. So let me keep this screen. So they're x plus 1 and x plus 3.
Miss Young,
Yes, ma'am.
we don't know what you're doing.
Okay. I wrote it really bad. We're going to multiply the 2x plus 1 times the x plus 3.
Are we going over a test question? This the work you're about to do, or what?
Well, this is just kind of, I had a question about factoring.
Okay, got it.
Okay, and I thought I'm going to try the algebra tiles right now to see if maybe that'll help some people understand it a little bit more.
Okay.
So I'm going to go back to my algebra tile question here. All right, so what we're going to do is we're going to build an array with it. So I'm going to take my 2 x's and line them up, and then the 1 here. So that's my 2x plus 1. And then I need to flip it, because I really need this to go sideways. No, don't want a negative. Okay, that one's supposed to lay horizontal,
Okay.
but it'll go right here, and then I have my 3 ones. So when I do x times x, I get an x squared. Okay, and then I've still got an x times an x, so that will give me another x squared. And then when I take this column, see, this works so much better. And then I have these ones. So when I do this x times 1, I get a 1x. This x times 1, I'm going to get a 1x. And this one. So that takes care of the first term times the other 2 terms. So what I'm doing is I'm taking my 2x times my x, where I get the 2x squared, and then the 2x times the 3, I'm going to get 6x. I'm doing something wrong. Oh, okay, because I've got to do this x times 1, because that's my second x, times each one of those. There's my 6x. And then I have the 1x times this x.
I don't think I understand this at all. Like, this is probably worse.
Yeah, this is worse. So let me work on that,
Okay.
and we'll come back to it. So, yeah. Let's go back to what I was going to do today. I'll try to bring my actual, I've got actual algebra tiles in my office, so I will try to remember to bring them. Stick my little note in there. Okay, so since that was a complete flop, but at least we tried, right?
Right.
You gave it a shot.
I gave it a shot. So we'll scratch that. Are y'all with me, Mark Tree?
Yeah.
Okay, we'll come back to it, but that'll have to be when I actually bring my algebra tiles. All right, so we're going to, this goes with section 2.2, linear equations. And we're going to solve for x. Even though they're linear, these are rational. Now let's just do a linear equation first. Because a linear equation generally either has an x or an x and a y, but they're they don't have powers. It's a single x, a single y. Also linear is when you have just a single x and no y, okay? So this would actually come out to be a horizontal line. But we solved linear equations. If you think back to high school, I know most of y'all had at least Algebra 1. If you can remember that far back, that's our problem a lot of times, is remembering that far back. So we're going to combine the like terms. If it goes across the equal sign, if this is plus here, all I have to do is subtract it from the other side, and then this goes away. It's like I'm physically picking it up and moving it. But when I cross that equal sign, I'm changing the sign. It's a little shortcut to keep from having to subtract from both sides and all that stuff. So then 7 minus 3 gives me the 4x. I'm going to bring down my 2, and it equals negative 9 because that 3x went away. And then same thing here. I want to get the 4x by itself, or the x variable, whatever. I've got to get rid of the 2. So it's positive, so I'm going to have to subtract it from the other side, and then it'll go away. So 4x is going to equal negative 9 and negative 2, negative 11. And then I'm going to divide both sides by 4. So x equals a negative 11 over 4. Okay, that just kind of gets us going. Now, if you have to do the minus 3x from both sides to show that it cancels, the minus 2 from both sides to show that it cancels, that's fine. You do whatever you need to do to get it right. Okay, you need to take all these little baby steps, Didn't take them. The Lord knows I did in graduate school, and I shouldn't have to take the baby steps, but it's habit for me. And so in grad school, I took the baby steps. And I teach a lot with the baby steps, whether y'all need them or not. I don't want to lose anybody. All right, so what we're going to move on to is these are rational expressions, which means that they're fractions with a variable in the denominator. Okay?
So we can clarify across.
Well, we've got to have the least common denominator, and I also have to know what my restrictions are. And I find my restrictions here. The restrictions is x cannot equal some number, okay? And it's whatever the number is in the denominator that's going to make it make x 0, okay? So I have x. If I just take my x, set it not equal to 0, and solve for x, well, that's x is not equal to 0. So that's my restriction. Okay? You always want to find your restrictions first, with just your denominators just like they are. It'll make more sense when we do another one in a minute. Then, what would my common denominator be? I say least common. I want just a common denominator. Well,
2.
out of 3 and 6, you know, they've all, what's the greatest number that they will all go into?
Oh.
6 is the greatest.
And then since I've got this x, I've got to have the x in the denominator also. Okay? Now, here's the shortcut with these. And I got to find my other colored pen. Is that we're going to multiply each one of the terms by our common denominator. So I'm going to multiply this term by 6x over 1. I'm going to multiply this one by 6x over 1, and the last one by 6x over 1. Okay? I'm multiplying all, I want to get rid of the denominator. That's the whole goal for my first step, is to get rid of the denominator. So when I do this,
No. So we're finding the greatest and not the least?
well, the least common denominator, or the greatest number that they all go into, is still the same. I don't want to say the greatest number. I want to
So we could
say,
have
it's just, hang on, I can barely hear you.
I'm just trying to understand which one. Do we,
Okay, it's technically the least common denominator, is what you're trying to find.
okay.
Okay, but we'll use any denominator, any common denominator.
Okay.
Okay?
This one is your walking.
Yeah, no boot. That's where I was Monday.
Okay.
Yeah, no boot, no crutch, no knee scooter. Yeah, that's where I went Monday. I have to go back one more time. All right, so to get rid of my denominator now, I'm going to look. What will my 6x and my x, what cancels?
The X.
The x. So this x cancels this x. Then between the 3 and the 6x, 3 will go into 3, and 3 will cancel in, have 2 left over out of the 6, right?
Hmm?
And then the 6 and the 6x, my 6's cancel. So now, what I'm left with, I've got this 6 here times 3, minus, and then I've got the 1 times the 2x, and it equals the 1 times the x. So, it's whatever didn't cancel times whatever was in the original equation.
So since it's all ones on the bottom, we'll just get 1.
Right, well, we never, if it's 1 on the bottom, we basically have a whole number, right?
Yeah.
So we just,
do 1x.
no, we don't have anything on the, it's just all ones, so we don't have to write anything there. Now, if you want me to, I can take this step, and since they're all over 1, then I don't have to worry about the denominator. So then I can just multiply. 6 times 3 gives me the 18. Negative 1 times 2x gives me the negative 2x. 1 times x gives me x. And now I'm just going to solve for x.
So divide by
Change
negative.
it up a little bit, Ms. Young.
Sorry, yes. Okay, well, I've got to get my x's together. So I'm going to add 2x to both sides, or just add the 2x over. And then 18 equals 3x, right? Divide by the 3. 3 times 6 is 18, so x equals 6. And as long,
X does not equal 6.
but no, x can equal 6.
Okay.
As long as it doesn't equal my restriction, as long as my answer and my restriction are different.
How do you know what your restriction is?
Okay, this is where we looked at the original equation and just the denominators. So I only used my variables. I had x, and I set it not equal to 0. And I solved for x. Well, x not equal to 0 is still x not equal to 0, right?
So 0 can't be in the denominator, right?
Right, because if you have 0 in the denominator, it's undefined.
So that's definitely a restriction.
That's definitely a restriction.
So what's another example of restriction? That's not the whole-
Only restriction. Yes, ma'am.
Yeah. You have the 2x on both sides.
So is it considered one egg or is she?
1x plus 2x.
Okay, so she just assuming it, so she's assuming that egg is one.
If you're
Okay.
doing
No, we haven't been here in a couple of minutes.
Yeah. All right, Marjorie, y'all have a question or just,
No, they got it.
got it?
Right.
Okay. All right, I'm going to do another example. Actually, I'm going to do several examples. We'll call this example 2 so we keep it straight. I'll move my board over in a second, or my paper.
Are there any specific place where these are coming from, or do you have something else?
Yeah, I have a paper I've got my examples on.
Okay.
Okay. So I have the whole number 2 minus the 3 over x plus 4 equals x plus 2 over x plus 4. And honestly, what I have done to get my examples, I'm using the, from chapter 2 or section 2.2, I'm using the homework.
Okay.
So this one is actually number 17, and it doesn't give me a page number. Yeah, I know. It doesn't give me a page number, but it's on section 2.2, but it's number 17. I'm going to make my whole number 2 a fraction. Okay? Because I need all of them to be fractions. And then I'm going to look for, again, a common denominator.
What is 84?
Well, but these are binomials, right? X plus 4 and x plus 4.
You said that's
Are
number
you gonna do
17?
the restrictions first or no?
I'm going to do common denominator, then I'm going to do the restrictions.
Okay.
It's just, you can do it either way. You can do the restrictions first, but I always think common denominator first.
Yeah, over 1.
Okay, so if this has got an x plus 4 as a binomial, this one has the x plus 4 as a binomial, and this is 1, my common denominator is going to be the x plus 4. Okay, so it's what does each denominator have? Okay,
And since it's 1, it doesn't have the same, so it.
yeah. Well, 1's 1. If I multiply 1 times anything, I'm still going to get, if I multiply 1 times x plus 4, I'd still get x plus 4, right? Okay, now my restrictions. I'm going to take the x plus 4, and since they're both x plus 4, I only have to do it once. Take the x plus 4, set it not equal to 0, then solve for x. So I'm going to subtract -4 for both sides. So x does not equal -4. So, and here's why it's the restriction. If I put -4 in for x, -4 plus 4 gives me 0, right? And then I'd have a 0 in my denominator. So that's why it's the restrictions, because we can't have the 0 there. All right, and now I'm going to rewrite this down here because I'm running out of room there. We're going to multiply each term. And some books teach it, and some teachers teach it that you're multiplying the whole thing by x plus 4 and then we write it once. I want to make sure that you're clear that we're multiplying each term by x plus 4. And I'm multiplying by x plus 4 over 1 because I need it to be a fraction. Okay.
Are you gonna upload these notes or?
I can. As well as the video, I can upload my paper, that's not a problem.
Never mind, you're right. I can just look at the video.
Yeah, but I mean, I don't care to upload the paper too.
Oh, no, that's fine. I forgot. I can just look at the video.
Okay. All right, so now I'm going to look what cancels, where it cancels.
You can cancel the X plus 4, the X plus 4.
Yeah, X plus 4 there, right? The X plus 4 and the X plus 4 there. Can I cancel anything with the 2 and the X plus 4? In that first term? No, because they're both, the denominators are 1. So then what I have left, I'm going to try to write this multicolored, is X plus 4 times my original 2. And then 3. I don't have anything, because when I cancel the X plus 4, these are both 1. So technically I'm multiplying it by 1. And then the same thing with my X plus 2, I'm technically multiplying it by 1 because everything canceled.
Where'd you get the? Oh, okay. Sorry.
All right. And now I'm just going to do the math. So I'm going to distribute the 2 even though it's behind it. I'm taking 2 times X and getting 2X plus 2 times 4 is 8. Minus 3 times 1 is 3. And then if I multiply X plus 2 times the 1, I'm going to get X plus 2.
And then you solve.
Yeah. Combine your like terms. I've got 8 minus 3 over here on the left. So that's going to give me 5 because 8 minus 3 is 5. And then I got my X plus 2. Now, since I got an X on each side, it doesn't really matter if I subtract X from both sides or if I subtract 2X from both sides, as long as I get them on the same side. Me personally, I'm going to subtract the smaller because I don't like dealing with negatives because I drop them, I lose them. So I'm going to subtract X from both sides. That cancels. 2X minus 1X gives me X. Then my plus 5 comes down and it equals 2. Then I'm going to subtract 5 from both sides. And I'm going to have X equals 2 minus 5 gives me negative 3. And then again, I've got to check, is my solution or my answer the same as my restriction? And if it's not, then this is my answer. If it's the same, if they both happen to be negative 4, then my answer would be no solution. Because your answer can't beat your restriction.
Are you going to make us do the restriction part or no?
Yeah, I probably won't have you put it in Canvas, but on a test, you'll have to know what the restriction is because once in a while the answer does equal the restriction.
So like if it was on the test and you have to put in the equation, you would just put
You'd put
restriction.
negative. Well, you'd put, what I'd have you do on the test is like, I give you this equation. The only thing you'd put in on the test would be like the negative 3. But on your paper, you'd have to show the restriction.
No, but I mean, we get it to restriction and then we get X.
Oh, X equals.
Equals negative 4, we would just put, no, like restricted or like what?
Oh, you'd put if it was the same. If your answer equals the restriction, you're going to put no solution.
Yeah.
Okay. And if you forget what to put, you put something like it's restricted or it equals the restriction or something let me know that you can't use that number for your answer. Then, and it has to do with the restriction, then I'll give you it to
So
you.
we can put both, put that in,
Yeah.
like no solution.
Mm-hmm.
So we show that we know that it was no solution.
Right. Yeah, if they equal, you have to at least somewhere tell me that it's no solution or that the answer matched the restriction or something along those lines. All right, so questions on this one?
Nope, I think I'm actually leaving class today with no headache.
That's good. I haven't given you one yet.
Oh, what? Oh, okay. I thought
Give me time. Okay, I'm going to do another one that's real similar to that one. This is number 19 from the homework. It's 3x over x minus 1 plus 2 equals 3 over x minus 1.
would it be -1 here?
Your common denominator is going to be x minus 1. Now, what about your restriction?
Would it have to be
X does not equal
1?
1. And you can do, I mean, I should have done this. X minus 1 does not equal 0, and then you're going to add the 1 over. So x cannot equal 1. Okay, so then what am I going to do other than put 2 over 1 to make it a fraction? So what am I going to do at this point?
You have to,
But
that's when you do the least common denominator by all three sides, all three sections.
All 3 terms, yeah. And that's basically what you were
X
saying.
minus 1.
So I'm going to multiply each term by x minus 1
Mhm.
over 1. Yeah, every term, everything.
Then you want to cancel out.
All right, then I want to cancel out. I'm going to cancel out with my purple this time. So what cancels in that first term?
1 minus x and 1 minus x.
Okay. Does anything cancel in the second term?
No.
No. What about the third term?
X minus, x negative 1, I mean.
Yeah, the binomials, the x minus 1, the x minus 1.
And then you want to write what you got left.
Right. And
Denominator.
since the x minus 1 canceled the x minus 1, I don't have anything other than my 3x. And you can do 3x minus 1 if you need to.
Plus 2x, 2, yeah, there you
Yeah,
go.
2 parentheses x minus 1, or 2 times x minus 1.
Yes, and then plus,
Equal, well, that's an equal.
equal 3.
Mhm.
And then the rest is all 1, so really no need to put that unless you just need a visual.
Right. Unless you just need a visual for the step to see that they're all over 1. Okay. Now, the restrictions only have to be done on the equations. If they're expressions, they don't have to be done. The restrictions only have to be done on the equations.
Another question.
Mm-hmm.
Okay, so if it's a 1, you just leave it alone.
Right.
When it's canceling. Because, like, the one next to 1 in the second one.
Like
The second.
this one.
One, yeah. See, I for some reason, I want to cancel those out for no reason, so it just kind of gets confusing. So you don't have to worry about that.
Yeah, same.
Yeah. I mean, but they're both on bottom, so there's nothing, I mean, you can draw a line through them. You could draw a line through that too if you needed to.
When I don't see a number that's a log, I just want to mark them all out.
Yeah. And you can't, it has to go top to bottom.
I know.
Yeah.
Ms. Young,
Yes.
would you ever trick us and there be a denominator? Or we could just,
No, the whole point in this is to get rid of the denominators.
okay.
So no, I won't trick you. I'll leave that up to Cal 1 or pre-Cal, if you get that far.
Yes, I sure do.
I think I said that in college algebra too. I wasn't going to go to pre-Cal or Cal or anything higher.
I don't know how you were actually a math teacher after you.
I was out in high school for 5 years before I went back. And then my degree is actually elementary
3
education.
years.
Yeah.
Or 4.
That's 9-3, isn't it?
Okay, so we solve this.
It's my, look out this world.
Distribute my 2x minus 2 equals 3. Combine my 3x and my 2x because it's on the same side. That gives me 5x minus 2. And then I've got to add 2 to both sides to get rid of the 5, or to get the 5 by itself, or the 5x by itself. So 5x equals 3 and 2 is 5. Divide by 5.
1.
X equals 1.
Oh,
Okay?
non-solution.
No solution. Because the x minus, or the x cannot equal 1 and the x equals 1, these are the same, so it's no solution.
Solution.
So when your answer is the same as your restriction, it's no solution.
So if you don't get your restriction right, your whole problem's going to be more than likely wrong.
Yeah, well, your final answer will be wrong.
Yeah.
You know, if you don't do your restrictions, let's just say at the beginning, technically you could find your x equals 1, but you have to go back to the original, get your
So
restriction.
let's say hypothetically, we're taking the test,
Mm-hmm.
and we have no solutions That means we probably did one of them wrong.
Not necessarily, because it could be that, because what I do, especially if it's now that I'm having y'all do your test online, is I may put 10 of these types of questions and have it choose 3. So it could choose 3 that are all no solution, or it could choose 3 that all have a solution, or you could have 1 have a solution, and any array of things. So just because you got all 3 of them no solution, or all 3 of them all solutions, or have solutions, doesn't mean you did anything wrong. And even if I was doing a paper and pencil test, depends on the mood I'm in that day, I may not give you one that has a no solution. So, don't ever count that just because you didn't get it doesn't mean you did something wrong. Okay? And then if I'm in one of those moods too, I might give you one that every solution is wrong.
Oh, Lord.
So, in other words, don't freak out because you got all no solutions, or you got, every one of them had a solution. Or 2 of them had no solution, and 1 of them had a solution. All right, so this time I'm going to do one that's a little bit different.
Right here.
See, this is the beginning and the end right here.
No,
Remember this.
not the beginning of the end.
I'm just gonna change it up a little bit.
That's what I said.
That's how it all starts.
I'm going to throw a curve in here.
We know that.
Like I used to say, I'm just going to throw you a little bit of a complication. That 2020 has been total complication, so I really don't want to go there.
It's actually been the best year of my life. I don't know how, but it's really been a great year for me.
I am really glad for you.
Me too, I've had to talk to
Yeah.
I mean, we had an extended vacation, and then we came back. So.
Everything was cheaper, so I got to go to the beach twice. And
We
I
didn't
started
have, we
third
didn't have to leave the house.
Oh,
Yeah.
see, well, I've had good things in 2020 because I didn't have to drive an hour twice a day from March to May. And then, I spent the whole month of July in Mountain Hall or in Henderson. So it had its good points, but
Yeah.
I mean, I broke my ankle.
I learned how to swim.
Well, that's awesome.
Oh, wait, how are you?
18.
Oh.
My son didn't learn how to swim until he was 18 either, and that was my fault because we had a pool in the backyard. It was above ground. Yeah.
Oh, yeah.
All right, so notice this one. I have an x minus 2 and x minus 1, and then this one has both of them. So our common denominator is going to be both x minus 1, x minus 2. Because that's the only things I have in my denominator, right?
Yeah.
All right, so it's just the 1x minus 1 and then the 1x minus 2. Okay?
Okay, so when there's 2 terms in one fraction, it's more likely to be both of them.
99.9% of the time. I don't want to say 100% of the time in this class.
Oh, good.
Just gotta look over here.
0.1% chance, so you miss it, and you're.
Then I'm gonna come to you and be like, hey.
I won't do that to you on this. I won't do that to y'all on this. Like I said, I'm gonna leave the trick questions to pre-Cal and Cal 1. If y'all go that far, because every year I have a couple that are going to go on and do something engineering or something that has to have higher level math. But most people just need college algebra. So I'm not going to put the tricks in there. I'm not going to try to trip y'all up. I'm going to teach you what I have to teach you to get the ones that are going on to where they can go on, but then I'm not. So I'm going to have 2 different restrictions this time though, right? I'm going to take my x minus 1, set it not equal to 0. So x won't equal 1. But I also have an x minus 2 in the denominator. So it also has to be set not equal to 0. So I'm going to move the 2 over, so x will not equal 2. So I've got 2 restrictions this time. And when you have 2 different binomials, or you have, 2 denominators that have x in it, you're going to end up with an x squared. All right, so I'm going to multiply each denominator, or each term by my common denominator
Over
1. So x minus 1, x minus 2 over 1. X minus 1, x minus 2 over 1.
I mean, not leave that safe enough for this.
Okay. And then I'm going to cancel. So in this first term, the x minus 2's are going to cancel, right?
Yeah.
Okay. In the second term, only the x minus 1's are going to cancel.
Uh-huh.
But now in the last term, my x minus 1's will cancel, my x minus 2's will cancel. Okay. So then I'm going to have x minus 1 times 3 equals
1.
1, or okay, we'll do that. 1 times the x minus 2 plus the 7, right? That's, what are you talking about doing backwards?
I got the equal sign was on the other side this time, so I decided that I did.
So say go left to right and pay attention to what's in the middle.
And then, where did the 1 come from?
This 1 times the x minus 2. You know about this
Did
one?
you do anything?
No.
Okay.
We'll just put it, I'm more or less,
We just talked about not having to put 1s in there.
and you don't have to.
Okay.
I'm putting it because Mark Tree mentioned the 1 times the x minus 2.
Yeah.
But, you know, you don't have to put that 1 in there. So I've got to distribute my 3. So I get 3x minus 3. And then the 1 times the x minus 2 is going to leave me with just x minus 2. And then plus my 7. So combine your like terms. You got the negative 2 and the 7 on the right. So that's got to be combined first. That gives us 5. So x plus 5 there. 3x minus 3 on the other side. Okay. So where do I go from here?
Gotta get rid of.
Now,
Minus x.
minus the x. So I get 2x minus 3 equals 5. Then what would my next step be?
Plus 3.
Add the 3.
2. No, 8.
8, because you're adding. If I'd been subtracting, you would have been right. So what does x equal?
4.
4. Because I'm going to divide both sides by 2.
Man, I royally messed that one up. I have to go and like rewrite it better because my numbers just get jumped.
Yeah, I used to go home every day after in undergrad and grad, go home and recopy all my notes.
Yeah, I went to go look at my notes for the test. I was thinking like trying to understand it more. Could not figure out what was going on.
That's usually good.
It pays to go home after class and recopy your notes so you can, while it's still kind of fresh in your mind.
Because in the moment it makes sense in my head, like, oh yeah,
I know,
I'm
that's
just
what
look at
I'm
it.
saying.
And then when you get home and you're recopying them and you're like, now, okay, I did this because, and you make yourself a note why you did this, you know. We're finding the common denominator and multiplying every term by the common denominator to get rid of the denominator. So you make yourself little notes when you get home to do that, or watch the videos again and make little notes as you do it. All right, so is x equal 4 my answer? Or is it equal to one of my restrictions?
It's your answer, it's good.
Yeah, it's my answer, so I'm good with it.
Isn't there one where you have to do 2 separate ones to make sure that both restrictions are not?
Yeah, if I have an x squared and I have to factor it, I have a quadratic, I have to. So far though, let's do one more of these.
Oh, no, I ain't leaving it because she cardinal stuff. So I'm here.
Let's see.
All right, so let's see. Draw my little line so I don't get confused. All right, I got 5 over x plus 1 plus 1 over x minus 3 equals negative 6 over x squared minus 2x minus 3.
Are you making this one up or are you still there?
Now, I'm still doing it. I don't make equations up, because when I make equations up, you get some flat out weird answers.
Okay, so question. So if you
Uh-huh.
have the last one, right? it's
Well-
multiple x, then?
No, because this is an x squared, right?
Yeah.
We can factor this one. Because it's x squared minus 2x minus 3. If I go over here, x squared minus 2x minus 3. And I'm going to single x squared, so I got x and x. Then what are my factors in negative 3? They're going to add to be negative 2.
What, so there's two different equations going on here?
No, I'm just having to factor this one. Anytime you have one that's written out as x squared minus the 2, written out as x squared minus x or plus x or whatever, it has to be factored. But 99.9% of the time, it will be your two extra factors over here. So it's going to be x plus 1 and x minus 3, because negative 3 plus 1 gives me negative 2, right? Okay. So instead of having the equation, I'm going to have x plus 1, x minus 3. So I'm going to write that there. So now I can go back to where I started and all these others. What's my common denominator?
X minus 3
And
and x plus 1.
x plus 1. Okay. And then what are my restrictions?
3, negative 1.
3 and negative 1, because I'm going to take the x minus 3, set it not equal to 0. So x will equal 3. Set x plus 1 not equal to 0. And x equals negative 1. Or not equal to, excuse me.
Sorry, give me a second. I'm trying to make this legible.
Yeah. Yes, sir.
When we do the last one, does it cancel out because those two make the
Yeah, just like we did in the one right before this. When we multiply everything by the common denominator, it'll cancel. So I'm going to take the 5 over the x plus 1, and I'm going to multiply it by the x plus 1, x minus 3 over 1, and then plus my 1 over the x minus 3,
The x plus 1.
and x minus 3 over 1, and then the negative 6, and I'm going to write it this time as x plus 1 over x minus 3 where I factored it. I'm going to multiply by the x minus, that's x plus 1, x minus 3 over 1. And I mean, I can start on the right side where both of these, the x plus 1s and the x minus 3s cancel. I can start canceling there. It doesn't matter where I start canceling. The middle term, the x minus 3s cancel, and the first term, the x plus 1s cancel.
Can you push it up a little bit?
Yeah.
Thanks.
So then I'm going to have the x minus 3
Times the 5.
is the 5 plus, I'm not going to put the 1 this time. I'm just going to put the x plus 1 because 1 times x plus 1 is x plus 1, right? And then equals negative 6. And am I having to multiply negative 6 times anything?
No.
Everything canceled.
So then when you distribute the 5.
All right, distribute the 5. I get 5x minus 15, because 5 times 3 is 15, plus the x plus 1 equals the negative 6. Okay. And then I'm going to combine my 5x and my x, because we're on the same side. I'm just going to add them together. So I get 6x. And then the negative 15 plus 1 gives me negative 14, and it equals negative 6.
Did it? Yeah.
And then I'm going to add 14. So 6x, and this is where we got to be careful. It's -6 plus 14,
Positive 8.
positive 8.
And then you want it to 6.
Yeah, divide by 6. So x equals 8 over 6, but I've got to reduce that. So 2 goes into 8 and 2 goes into 6.
4
So
to
we
30.
get 4 thirds. And leave it as 4 thirds. Leave it as an improper fraction. So does the 4 thirds match our restrictions? No. So the 4 thirds is my solution. Okay?
I'm fine with keeping those as a fraction.
The fractions throw, when the answer's a fraction, it throws people. And sometimes it can mean you did something wrong, and most of the time, though, you're right.
Well, that was saved me this time, because I kind of jumped ahead and I got a fraction, so I was like, oh man. So I went back up, and it turns out I had a -1 instead of a +1
Mhm.
on one of them, so I got lost, so then I went back and I ended up still doing it.
Yeah, I still
Yeah.
have the +3. So let's scratch out.
Yeah. So you gotta work out, or watch out what you're writing down, because we transpose. When I graded some tests, they had transposed the numbers in the problems.
On the list, where we,
I think it's Let me look.
Okay. So we have questions? I think they're okay. All right, y'all ready to switch gears?
yes.
Okay. Switch gears and do something a little bit easier.
Oh, a little bit easier.
Yeah, we're gonna, no, I really don't want to switch gears, honestly.
Now, you are getting this. You don't want to switch gears. All right. So what we're going to do this time is when we're writing the equations of lines, and writing equations of lines are linear, so that goes along with our linear equations. So if I'm writing equations of lines, there's two forms that we can use. There's the point-slope form, and this one is actually my favorite because it's easier, which is y minus y1, y sub 1, equals m times x minus x sub 1, okay? You use this when you're given the slope and a point. And your point's x1, y1.
This has been so long since I've done this.
And then we have the slope-intercept form. And our slope-intercept form is y equals mx plus b. And you use it when you're given the slope and the y-intercept. And the y-intercept is 0 and y. No, 0 and b, excuse me, on this one. So m is equal to my slope for both of these equations. M is always your slope. And b in the slope-intercept form is my y-intercept. Okay. Now you can use the slope-intercept form to find your equation of the line, regardless if you're given just the y-intercept or if you're given a point or 2 points. So, you know, a lot of high school teachers will teach just the slope-intercept form, but I have found that the point-slope form works better for any equation that you're going to write the equation of, unless you're given the slope and the y-intercept. So let's look at this first problem. I'm given 0 and 3.
We can't see it over here, Miss Young.
I'll fix it.
Okay.
Slope of 2/3. All right. So So the 0 and 3, the 3 is my y-intercept, right? Because it's got 0 for x. If you have a point that has 0 for x, then your number is your y-intercept.
So the second number is always the y-intercept.
Mm-hmm.
Because it's x, y.
Yeah, it's always x. Well, let's say it's always xy. For this class, it'll always be xy. If the x is 0, then the number is your y-intercept. So then I know that my b is going to equal 3, and my m is going to equal 2/3, because m is slope, and the y-intercept is b. And I can use my slope-intercept form and have y equals, I'm going to use the y equals mx plus b. So I'd have y equals 2/3 x plus 3.
So can we not just plug that into a calculator?
Yeah, and graph it, yeah. If we're going to graph, I'm not going to graph today.
And that would just be the answer.
Because I just want the equation of the line. And a lot of times they'll say, write the equation of the line in slope-intercept form.
And then have you graph it.
Yeah, and then that would be, you would be finished right there.
Because wouldn't it be like, because the 3 is the,
3 is the y-intercept.
yeah, so it'd be like 3 up on the y-axis, and then 2 up, 3 over, 2 up, 3 over.
Yeah, when I graphed it, but that's right. All right, let's use then this next example. I have 1 and 2 for my point, 1, 2, and I have a slope of -4/5. Okay, so this has got my point and a slope, so I'm going to use my point slope formula. The y minus the y1 equals the m times the x minus the x1. Okay, my point is always x1 and y1. And then my slope is the m. So the thing you have to remember when you're plugging into this one, the y that doesn't have a subnumber, the y is y. It doesn't change. But my y1, I'm going to put 2 in because that's what the point is. My m is the -4/5. X stays x, but then the x1 becomes whatever my x1 is. My x1's 1. Okay. Now, when I solve it for y, because this is where you've got to solve for y at this point, it will end up being in slope-intercept form. So I'm going to distribute the -4/5. So I keep the y minus 2, -4/5 x. Then negative times negative gives me a positive. 4/5 times 1 gives me a positive 4/5. Okay.
Yeah, that one's going over my head too.
Fractions always mess with everybody's heads. But all I'm doing is, the -4/5 times x, I get the -4/5 x. It's a negative times a negative here, which makes this a positive. And then the 4/5 times 1 gives me a positive 4/5. Then I've got to get y by itself, so I'm going to add 2 over. And I'm just going to flat out tell y'all, add the 2, take the 4/5 plus 2. It's a lot less headache for you. It's going to be 14 over. I've got to do, I can't do this in my head. So 4/5 multiplied by 5, 10 over. Oh, wait, I didn't do something here. Times 2.
Is it 1.2? Or not?
It's 18 over 10.
I'm lost.
Okay, y'all don't do this. Don't worry about this. In your calculator, because I don't have a calculator with me today.
So we just basically times it 2 times 4 and 2 times 5.
No.
Oh.
In your calculator, put your fraction 4/5, hit add 2. I wish I brought my calculator with me. So, do it on your calculator. I can't, the calculators I have in here. I wonder.
It's 14/5. I don't know.
You keep wanting to give me the decimal.
Yeah, it will a lot of times in your calculators. And when you have fractions like this, if you want this last number, then it would be 1.8. If you want to put it in as a fraction, I'm okay, or as a decimal, I'm okay with that. But if I do 4/5 times 2, I get actually 1.6. 4 divided by 5 times 2.
I thought you were adding the 4/5 question plus 2.
All right. I'm doing 4/5 plus 2. My common denominator is going to be 10. I multiply that by 2, this by 5. No, that's what I was doing wrong. It's easier. I'll have to wipe that off in a minute.
You lied.
Only because it's a fraction.
Well, you should have gave us an easy one, Star, no.
1.6 sounds good to me.
Yeah, we'll use 1.6. That's what my calculator gave me. So then your answer is y equals a negative 4/5 x plus 1.6.
Can't pay attention to
That was a fraction question.
We'll start with third graders.
I'm not writing that. No, yeah.
I'm done. I mean, that's it.
Okay.
Yeah.
What,
Miss Young,
do what?
you got 2 questions over here.
Okay.
How did you add 2 and get a number less than 2? It should be 2.8.
Yeah.
Okay, because 4/5 is less than 1, right?
Right, but you're adding 2, so it should be 2.8.
Yeah,
Yeah, it should be 2.8.
okay.
I'm not writing down yet.
Yeah, you were smart.
What are you saying?
I don't know who's over there, but they sound really smart.
Don't read it like my
Yeah.
So 14 over
I just-
5.
I was really confused about why I was.
I was just gonna agree because I had no clue what was going on.
So I was like,
I was trying to do it in my head, and that's where I made my first mistake.
If it's over 5 and you have 2 already, that's just 5.
It's-
5, that's 10.
Yeah.
That's 10 is 14.
That's why I came up with 14 over 10 the first time, because I was putting 10 on the bottom.
Yeah, I agree with everybody.
Yes. It's not a good thing to do.
This is a great debate.
Okay.
Better than all that stuff.
I watched about 5 minutes and slept through the rest.
I wasn't about to turn it on.
What?
Until yelling at each other.
Of what?
The debate.
Oh my gosh. Oh, don't even get me started on that.
All right, yeah, let's go and do this one. And this one, I'm not adding a curveball, really. I'm not adding complication, but we're given 2 points. The first thing you have to find is your slope. Because if you're given 2 points, you can't, you don't know what your slope is. So you have to find your slope. And your slope formula is m equals the difference in the y, so y2 minus y1, over the difference in your x's, x2 minus x1. So my 2 points are x1, y1, x2, y2, okay? Just to keep them straight. I always go left to right, that way I'm keeping my points or.
I remember this one the most.
So y2 is negative 6 minus y1, which is 10. x2 is 5 minus x1, which is negative 3.
I mean, can we do it the opposite way?
y1 minus y2 and x1 minus x2?
Yes.
Yeah, as long as you're going the first one minus the second one both times. You gotta go, I can't do y2 minus y1 and then x1 minus x2. I can't do that because then my sign will be wrong.
Okay.
Okay, so we could go, you could go y1 minus y2 over x1 minus x2.
Yeah, that makes more sense to me to go with the,
Okay, yeah, you can do that as long as, like I said, as long as you're going the same way with both of them.
Okay.
Okay, you will still get the same answer. So 6 minus 10, or negative 6 minus 10 gives me negative 16. 5 minus a negative 3 is the same thing as saying 5 plus 3, right? Which is 8. Negative 16 divided by 8 is a negative 2. So my slope is negative 2.
Is that it?
Well, we gotta write the equation of the line. No, not quite. So since I've got a point, I've got 2 points actually, and I've got the slope, I'm gonna use my point slope form. Okay, I can use either point, it doesn't matter, because both those points are on my line. But since I've got y1 and x1, I'm gonna go with the first point. So I'm gonna have y minus y1, which is 10, my slope, which we found to be negative 2, x minus x1, which happens to be negative 3. Okay? So just kind of do your math. I'm going to do the negative 2. I'm going to take care of the minus the negative 3 and make that x plus 3 because it's just easier to distribute the negative 2. So then I get negative 2x minus 6. Then I'm going to add the 10 over. And y equals negative 2x. So negative 6 plus 10 is
Positive 4.
positive 4. And then that's the equation of your line. So is that one a little bit easier?
Yes.
I was just trying to keep up, so.
Yeah, I just got done writing, so I mean,
That one.
it feels easier. As long as I.
As long as you don't, yeah, so remember all the steps. And it's easier when you don't have fractions involved.
Okay.
You know, once you get, if you put the fraction in for a slope or something, that's where it gets tedious. You've got to work with that fraction in there, and nobody likes fractions. I don't like fractions. I like nice rounded whole numbers.
I could even go back to that.
There are times when I need to go back to adding. Okay. So I've almost taken up the whole time. But I think, do we need to do another one of these?
No, these are easy.
You think these are easy? What do you think, Marjorie?
Oh, no, we're fine.
Okay.
I think I need to sleep on it, I'll give you
That
that.
way.
All right, well, let's look at something. I mean, it's still lines, but if I have a horizontal line, okay, horizontal, that's the flat line. If I put it on a graph, so here's my graph, my x-axis, my y-axis, and I have a horizontal line. And I'm just going to put it right here. Okay? It crosses my y-intercept, or my y-axis, at 0 and whatever it is, whatever that number is, right? At 0 and b. The equation, all these other numbers, x and y here, that's all going to be x and b, because they're all going to be the same thing. This would be negative x and b. This would be positive x and b. Because it's horizontal, it's flat, they're going to have all the same y values. All right? So my equation is y equals b, whatever my y-intercept is. And then I have vertical lines. And it works the same way as the horizontal line, except that it's only going to cross the x-axis. What color do I want to use? So it's going to cross right here, okay? And I'm going to use A for my x because I use B for my y. So this would be, what?
Can you scale it up a little bit?
Yeah. So this would be negative A and 0 because my y is 0. But every point on this line is going to be negative A. Okay, so, and if I was to draw it over here on the other side, That one's negative A because it's over on the left. If I was to draw it over here on the right, this would be positive A and 0. Up here would be A and Y. Down here would be A and negative Y. Okay, so this time they all have the same A value, or the same X value. So X is going to equal A, whatever that X coordinate is, whatever that X intercept is. So there's no, I mean, the horizontal line has a slope of 0, so you can actually put it into an equation and come up with the equation of the horizontal line. But the vertical line, you can't really put it in. Well, I guess you could, but it makes a difference because the slope here is undefined. So it's really hard to find the equation of a vertical line by using a formula. In the horizontal line, my slope is always 0. Okay. So we will pick back up here. Today's Wednesday, next Monday.
And we don't have to come Monday. We come Wednesday.
No, we gotta come Monday. Unless you want to do some stuff on your own. Yeah, we'll be here Monday unless, something drastic happens. It is 2020. So. I've had enough disasters. All right. I need a break. And not a little break. All right, so. Y'all have a good week. Y'all remember that Miss Morgan's not going to be there Monday? And somebody needs to probably go hunt up Mr. Nave if nobody shows up for that class to start everything.
Okay.
All right, thank you.
You're welcome.
So,